Hello, welcome to Astronomy Live. Tonight, I'm going to be webcasting Venus, which is what we're seeing here. But why does Venus look full? It's supposed to be a crescent phase currently. Well, we're going to take a look at a couple videos that show this and see if we can figure out why this is happening. All right. Got the telescope's hand controller here. Move things around a little bit. And let me get some of the show stuff going here. Let me pop out the chat so I can see what people are saying. All right, so why am I doing this? Some of you probably already know what this is, what's really going on here with Venus, but you may be wondering why I'm doing this. So I'm going to show you. Let's see here. Let me screen share for a second and set this up. So this is a recent video on WSO channel. And I've been seeing comments about this sort of thing propagating over to my channel quite frequently in the last few weeks, especially in the last number of days. I keep getting questions about this. And actually, Daz the cameraman asked me to do a video on Venus because of this. So this video, WSO awesome footage, Venus at 2000 magnification zoom from Finland. Okay, so they showed this video of fuzzy Venus. Oh, look at this, using a Nikon P900. All right, great. So let's assume this is 2000 magnification for a moment, which I don't know if that's necessarily true or not, but here's the problem. You can set any telescope to any magnification, but that doesn't mean it's going to be useful magnification. There's a difference between magnification and useful magnification. So magnification is simply a function of the telescope's focal length divided by the eyepiece focal length in the case of visual observing. There's a similar formula for CCDs involving the size of the CCD pixel, but the point is, magnification, you can just pop in a different eyepiece with a very small focal length and theoretically achieve very high magnifications, but that doesn't necessarily mean it's going to be useful magnification. Once you go past useful magnification, you're just over magnifying a blur. There's no more resolution there. It's like looking at a TV, getting, say, a standard definition TV and zooming up close to it with a magnifying glass. You're going to see individual pixels. Obviously, you're not going to see individual pixels in a telescope if you're just using an eyepiece. There's no pixels. But you will lose useful resolution. So you'll just be continuing to magnify a blur that you can't bring to focus. It will never become sharp because you've exceeded the optical resolving resolution of the telescope. And how much is that? So the theoretical limit of useful magnification of a telescope is 50 to 60 times the telescope's aperture in inches, or about two times the aperture in millimeters. So if this were a 2000 magnification image, first of all, that would mean in order for that to be useful magnification, the original optic would have to be 1000 millimeters in aperture. That's 1 meter. That's a 1 meter telescope. That's insane. There are very few amateur telescopes anywhere in the world that large. And even if you buy a high-end, large obsession telescope, you're still not going to be looking at something that big, generally speaking. So obsession telescopes, they make some really nice Dobsonian truss tube telescopes. And if we come over here, let's look at their telescope offerings. 12.5-inch telescope, $3,500 basically. Keep going up and up and up in size, and the maximum they offer right now seems to be this 22-inch f4.2 Dobsonian truss tube telescope. This is a $10,000 telescope, and that's actually cheap for that much aperture. You can easily pay a lot more than that if you get, say, a high-end plane wave or something. So the claim that this is 2000 magnification of useful resolution is garbage, especially with a Nikon P900. A Nikon P900 does not have a 1 meter aperture. Now, they might make claims about how much magnification that camera offers, but sometimes they cheat that by doing digital zoom. I don't have a P900 myself. I don't know the details on the specs of it all, but I know it doesn't have a 1 meter aperture. And yeah, maybe you could like digitally crop the corners of the image to make it and blow it up to make it look larger and even more magnified. So yeah, there's even saying here digital zoom. It's not useful resolution. You're just zooming in past the useful resolution of the camera. So why does it look like this, though? Why does it look like a full circle? Venus is supposed to be a crescent phase currently. And if we come back to my video here, so this is live video from my telescope. Oh, it's the same thing. It's a big circle with little dots and stuff on it. Yeah, that's because it's out of focus. I'm serious. It's out of focus. And in this, in this WSO video, they don't seem to know that. I don't know what their deal is. I mean, they don't seem to know much about astronomy, but let me show you what happens when I focus the telescope now, okay? All right, there we go. Venus is a little crescent. That's what Venus actually looks like when the telescope is focused and the exposure is set properly so it's not overexposed. That's what it actually looks like right now. It is a crescent. Let me zoom in on that digitally, just like the P900. The wonders of digital zoom. I'm still overexposing it slightly here, but not by much. That's why you get that glare on either side of it here. That's a bit better. Okay. Yeah, that's what Venus actually looks like right now. Now, we don't have a whole lot of resolution to work with here because I'm using the small 80mm refractor piggybacked on top of the LX200 because the out-of-focus image takes on the shape of the optics. And in this case, the refractor is just a big circle. There's no central obstruction or spider vein or anything. And that's what you see in that Nikon image. It's just a refracting type lens. And so when it's out of focus, the image it produces reflects the shape of the optic, in that case a circular lens. So to replicate that, I use the refractor right now, but I can pop it on the main telescope here in a minute, and we could take a look at what that looks like as well, where there's even more useful optical resolution. Yeah, Gaza or Sean, if you could just let people know in the chat if you're having trouble seeing it or hearing it. It's on YouTube's side, and it's a problem viewing, not a problem with me streaming it up. So just come back later and view the replay. I'm sorry to have to do that, but I don't know what else to do. So I'm gonna press on here. The image is going to be pretty stationary at the moment. If you're seeing a stationary image, that might be normal, but I'll change it here. So let's just recap again one more time. Venus is currently a crescent phase, and that is what you're seeing right here, right now, through the refractor. And I'm going to put it deliberately out of focus to show you the same image you get on a lot of these WSO videos. All right, and this is what people are reporting as proof that Venus is full right now. And sometimes, if you have really bad seeing or you have a heat source that the telescope is looking over, you'll get interesting distortion waves in it too. So I'm going to rub my hands together here and then put it close to the optic of the telescope, and you'll see. See all those distortion waves? Any heat source will do that to the image. Yes, this is Venus, but it's out of focus. And this is what you're seeing in videos like hang on a second. Close that. Videos like this one. So that's what you're seeing here. Seeing the same thing. The focus is shifting a little bit here, which is causing the circle to grow and contract. And you have all these little spots on it from dust in the camera, just like you see in my video. And then you have other videos like this that show the same thing. It's the same thing. It's just a little smaller because it's a little closer to focus, but still out of focus. But it doesn't tell you anything about the true shape of the object. It tells you only information about the shape of the optic that is recording the object, not the shape of the object itself. So, let me refocus the telescope. table. So that is the true shape of Venus right now. So I'm going to put it on the main telescope now, and we'll take a closer look at the crescent of Venus. Oh, there we go. Forgot I had the digital zoom on. So now the shape of the out-of-focus Venus takes on a donut shape, because this is a catadioptric 8-inch Schmidt-Cassegrain. So there we go. Tell you what, I'm going to take a moment and zoom in even more optically. I've got the focal reducer on there right now. Let me take that off. So again, it's going to be way out of focus to start with, but not sure which way will be the right way to focus. Here we go. Here's the right way. You can see Venus is starting to get a lot lower now than at the start of the webcast. And this telescope has a lot more optical resolution, so you see a lot more heat waves. And I'm not even doing anything to increase that. That's just heat coming off of roofs and trees and everything else as Venus gets low on the horizon here. So mirror flop. There we go. That's a pretty nice image of Venus, actually. So is anyone still seeing the webcast? People are still having all kinds of trouble, but some people are, some people don't seem to be having trouble. Is anyone still receiving me? Okay, some people are still receiving. So somebody asked, why is it sideways? That's a good question. And that has to do with field rotation. So this telescope is set up in an altitude azimuth configuration, and therefore field rotation is a factor, and it will appear to rotate from rising to setting, and it will look sideways as it sets, depending on where you are on Earth and where Venus is in the sky. It's the same thing that happens with the moon, and I've got a spreadsheet that calculates all of that. Yeah, sorry, I turned off the audio there for a moment. Somebody asked me, have I seen the Hubble Space Telescope with my telescope? And yes, I actually have. I've got a video tracking Hubble and actually confirming that Hubble was pointed where its schedule said it should have been pointed in space, which was kind of cool. I was just able to resolve the shape of Hubble's optical tube. And I'm trying to find the link to that video here. Where is it? Here it is. Okay, I'll drop that in the chat. You can see that. I'm not using any filters. This is just straight through prime focus on the telescope right now. And this camera is infrared sensitive as well. And I'm not using any kind of infrared blocking filters. So this is visible light plus infrared light. Coordinates. Well, let's see. I don't have my spreadsheet loaded up at the moment, but I've got a Venus calculations spreadsheet using Newcomb's formulas, and let's see. The azimuth is 85 degrees from due south. LX200 is kind of wonky. 0 degrees is due south on the LX200 Classic. So it's 85 degrees west of due south. 86 now, just hit 86. And about 20 degrees, 17 minutes elevation. So I think that's like, let's see, that would be, is that right, 286 degrees? Something like that. Or no, it would be 266. Yeah, that's about right. According to my spreadsheet, for my approximate location anyway, the azimuth and altitude at the time I mentioned should have been about 20.2 degrees altitude and about 266 and change in azimuth. Where is the moon tonight? Well, the moon should be, I think, now waning very gibbous, almost full. So it should be rising a little while after sunset. Let's see, the current time, according to my spreadsheet anyway, it's 95% full, and it's about 2.5 degrees below the horizon from my current location. Thanks for coming, Sean. I appreciate it. So I'll probably be wrapping up the stream here pretty soon. Venus is getting low. It's going to start hitting the trees before too long here. Oh yeah, Kaiser Cube. I saw that. Suggestion about blocking out Venus with a piece of tinfoil so you can see the moons. It's a clever idea. So you guys have any more questions about Venus? I've already addressed, the identity of the object and the brightness of the object in previous videos. I'm not going to rehash all that tonight, but I just wanted to address the comments about it being full when in fact it's really just a crescent phase. When you have it properly focused and you have enough optical resolution to see the true shape and you've got the exposure set properly, like you see here. But when you don't have those things set properly, yeah, it can look like a big circle because it's out of focus. And, I'm not trying to pick on WSO in particular here, but, I get questions about this stuff. So I have to address it, and that's what I'm doing. And I know WSO is not the only one, I'm sure, pushing those claims, but they're one of the most prominent ones pushing those claims. And, here on this channel, I try to provide real astronomy. And sometimes that means refuting false claims, because I get questions about it, let's face it. And if you just let those things fester, people end up being misled by them. So, I have to point out, I don't see this kind of footage showing up on channels like WSO, or the Beer Planet channel, or any of these others. Real high quality footage of these events, of Venus, of Comet 45P, etc. So if you want some real astronomy coverage, you have to go to the source for that kind of coverage. Real amateur astronomers like myself. Oh, Bobby in the chat thinks I'm a troll. I'm not a troll. I'm an amateur astronomer. I'm doing this not to troll people. I'm doing this to provide the truth. And this is the truth of the matter. I mean, show me where I'm wrong. I'm open to debating this and to discussing the facts. But if I'm wrong, then show me. Show me where I'm wrong about this. The binary system. Well, I could do a whole nother webcast on those claims. There's clearly not a brown dwarf anywhere near the inner solar system, the area where the planets are located. There's just not. Now, whether there's a large planet that's farther out, maybe. If there were a brown dwarf even out to Oort cloud distances, there's a good chance that the WISE telescope survey would have found it. So the odds of that are not good. But there could be a very large planet, several times Earth's mass or more, at Oort cloud sort of distances, or at least much further away than Pluto. We're talking hundreds of AU. So hundreds of times the distance to the sun. And, such a thing is not doomsday. It's not a threat to Earth, at least not directly. Now, there's a theory that when it gets out to Oort cloud distances, maybe it occasionally shuffles up the orbits of the Kuiper Belt objects that become comets as they come into the inner solar system. And so you get occasional periods where there's a heavy amount of cometary flux coming through the inner solar system. You can have extinction events from that. But terms of direct threat of something coming into the inner solar system and being visible by eye and causing doomsday on Earth, no. Not happening. And it looks like Venus might be setting for good now for the night. Kaiser Cube's completely lagged out, got nothing. Oh, man. Well, we'll have to see if the stream looks okay after it's done. Hopefully it'll be okay as a recorded video once YouTube gets its act together. But I've got really strong Wi-Fi signal right now, so it should be okay. Well, so Planet X is... am I saying Planet X is aligned? Well, the Planet 9 theory, you could describe it as a sort of Planet X. It just means an unknown planet that they're searching for. It's the latest incarnation of that, and it's a real scientific theory, and it might be real. It might really be out there, but it's not a conspiracy theory version. That's the difference. It's not something that is going to cause doom on Earth. Yes, it has gravitational effects on the solar system over millions of years, but not of the kind that would cause devastation on Earth. Okay, and it's not about to swing through the inner solar system and show up in webcams and cell phone shots. That's the conspiracy version, and that does not exist. So it seems like people are having some more people are having more trouble with the feed. And it seems like it's just YouTube timing out. So the powers that be don't want me webcasting Venus for some reason. Why is Skyview? Well, Skyview hasn't. If you look at it on the IRAS images, you'll notice it's not blacked out. It's only that section of the sky is missing in the IRIS version, reprocessed version of the IRAS images, but not in the original IRAS images. And that's just Saturn. It was doubly exposed, and it was eliminated later on because it's sort of an anomaly to the all-sky survey. All-sky surveys generally do not include planets in them. They try not to. So they cut that out of the IRIS version later. All right. Well, I'm going to have to wrap up the stream now. Venus is setting, but I hope you all enjoyed it. And thank you all for watching. Clear skies, folks. If you liked, please subscribe for more. Astronomy Live, signing off.